This is your day 5 homework. It's about compound inequalities. And a compound inequality is kind of like a compound sentence. A compound sentence is two sentences that are combined with the word and or the word or. And so a compound inequality has the word and or in it. It's two inequalities put together with the word and or the word or. You have been used to seeing ordered pairs represented with parentheses or brackets. There's another way to use parentheses and brackets. It is called interval notation, and it's a way to represent a set of numbers. For example, you could have for 2, I'll do it in a way that it actually makes sense. You could have 2 comma 4, which means all numbers in between 2 and 4, but not including 2 and 4. So that's the definition of a parenthesis and interval notation. It is in between those two numbers but doesn't include those two numbers. If you want to include the number, you could say brackets 2 through 4. So these are all the numbers between 2 and 4, including 2 and 4. This is going to be important. If I want to say negative infinity to 5, negative infinity always has an open bracket, meaning a parenthesis instead of a closed bracket. So if I wanted to write the set of numbers between negative 2 to 2, and we're including negative 3 to 2, and we're including negative 3 and 2, you would say negative 3 to 2. And notice the closed brackets because I'm including those two numbers from negative 3 to 2. This one says negative 5 is less than or equal to x is less than 1. So I'm going to break that up. I'm just going to take this part. This part means x is greater than or equal to negative 5. And then this part means x is less than 1. Okay, so if you put those together, you want including negative 5 and all the way on up to 1, but not including 1 because it's less than 1, it doesn't include it. So you can have an interval notation where 1's a closed bracket and 1's an open bracket. Write the inequality x is less than 1, or, this symbol means or, it's a V, or it could be a U, but it means or x is greater than or equal to 7. Okay, this is the interesting part. If I want less than 1, I want every number less than 1, and so you keep going, and the lowest number you can have is negative infinity. So we're going to use an open bracket because you can't ever actually reach infinity, so you can't include it. We want negative infinity up through 1, or we're going to use that V or that U. I want 7. I actually made a mistake because we do want to include the 7. It says x is greater than or equal to 7. We want to include that 7. And we want to keep going all the way up and up and up and up and up, and up until we get to infinity. And so that's how you denote that one. A compound inequality is two inequalities that are joined by the word and or the word or. Just like if you said compound inequality is two inequalities that are joined by the word and or the word or. Here's the first example when they're joined by the word and. When they're joined by the word and, you're going to see a upside down U, or it could look like an upside down Z. Oh, and here's the spot for that. Okay. You can write the compound inequality as x is greater than or equal to 5 and x is less than or equal to 7. Or you could write it where you put them all together. You could say x is less than or equal to 7, and then you could make it in the same thing. So I just have kind of smushed them together. Negative 5 is less than or equal to x, which is less than or equal to 7. Or if you use our new interval notation, it's got a closed bracket because negative 5 is included, and it goes up to 7. It's got a closed bracket there too. The confusing part about the interval notation is that if they're both parentheses, make sure you know that it's not an ordered pair when you're dealing with inequalities. Graphically, it looks like this. We're starting at negative 7. Put 0 there, we're starting at negative 5. Put 0 there, make 7 a little bit further away, and we're including negative 5, we're including 7. And we want all the numbers in between. So it's not an arrow anymore, it's a connecting bar, if it's the and one. All real numbers that are at least negative 2 and at most 4. All right, at least means negative 2 or more. So x is greater than or equal to negative 2. And at most means 4 is the biggest number, so x is less than or equal to 4. You could also write this in the bracket notation, and you could say between negative 2 and 4. And if you graphed it, it would be negative 2, here's my 0, here's my 4. And we are in between these two, and we're including. Today's temperature will be above 32. Okay, so it's not equal to 32, it's above 32. But not as high as 40. Not equal to 40, doesn't get up there. So you just have to be kind of careful with your reading. X is greater than 32, and x is less than 40. So in this case, it does look like an ordered pair, because 32 and 40 are not included. So that could get confusing. It depends on the context. You know, we're talking about an inequality here. The direction says write a compound inequality. So that's how you know that we're not dealing with ordered pairs anymore. We're not dealing with a graph. We're dealing with a set of numbers between 32 and 40. And if I graph it, these have open circles because 32 and 40 are not included. And then you connect them because you want all the numbers in between there. Today's temperature could be in between 32 and 40, but not including 32 and 40. Solving. Okay, these both look a little tricky because they have, you could split them up and solve them both separately. I could do that for one of them and then the other one do the other way. Or you could just solve it all together. For example, negative 4 is less than r minus 5 is less than or equal to negative 1. So just like a regular equation, you want to get this variable alone. So what is inhibiting that variable from being alone? That negative 5 is the problem. So how do you undo a negative 5 you add? The only difference is that you have two inequalities going on, so you really have to add it to both sides. Negative 4 plus 5 gives you 1 is less than r is less than or equal to 4. So I'm between 1, but not including 1, and 4. So if you don't like the way that looks, that's fine. You could separate it. What this really means is r, let's see, I'll write it in like a bubble. Just an alternative way to think about it. It really means r is greater than 1 and r is less than or equal to 4. You can split them apart. That's totally fine. So I'm dealing with 1, 4. 1 is not included, 4 is, and they are connected. We've still only done ones that have an and in them. That's why they are in between two numbers. Or is going to look a little different, but all the and ones are in between two numbers. I'm going to show you a different way to do number 8. I'm going to split it up first and show you how to solve it separately because some of you might like it better that way. I'm going to take just the yellow part and I'm going to solve that first. So I'm going to do, let's do it in green. So if negative 3 is less than 2x minus 1, just going to take that part first. Because you guys know how to solve this. You add 1, you have negative 2 is less than 2x, you divide by 2, you get negative 1 is less than x, which you guys know is really x is greater than negative 1. Okay, now, I'm going to get rid of that yellow and show you the other side of it. 2x minus 1 is less than 7. So notice the 2x minus 1 is repeated, which is why they are able to make it a smushed inequality. 2x minus 1, sorry, that's supposed to be 2x minus 1 is less than 7. You add 1 to both sides. You get 2x is less than 8. You divide both sides by 2. And you get x that's less than 4. These are both going to have open circles. And you're going to go right in between. Greater than negative 1 and less than 4. So you could solve the whole thing simultaneously, which means at the same time, or you could split them up and solve them both separately. Totally up to you. Symbol for an or inequality. It's the U or the V. They're the right side up, basically. The ands turn them upside down. You can write the compound inequality as x is less than or equal to negative 1, or x is greater than 4 as, using interval notation, let's get a pen for this. You could say, all right, if I'm below negative 1, there's no lower bound there. We just keep going and keep going and keep going. So my lower bound is actually negative infinity. And I'm going up to negative 1, and I'm including negative 1. Or not including 4 and going up to infinity. And so that is how we could write an or statement. And what that would look like graphically is we are going from negative 1, which is a closed circle. We're going down to negative infinity. So notice now the arrow comes in because it keeps going and going and going and going and going. 4 is an open circle because we're not including 4 in it. It's going an arrow in the other direction. So and is connected and or is going apart from each other. And there's always a space in the middle for ors that doesn't get included at all. And so now we're going to take a couple examples of that. We've got all real numbers that are less than negative 3, or they are greater than 6. And so you could also write that as negative infinity to negative 3, open bracket because we're not including negative 3, or to u, 6, open bracket because we're not including 6, up through infinity. And the way that that would work is you would see the negative 3, and you would see put 0 there, we'll put 6 there. You know, kind of try to space them out like a normal number line would look like. The distance between negative 3 and 0 is half that of 0 and 6, so I tried to space it out that way. So we have an open circle at both, and we're going down to negative infinity, and we're going up to positive infinity. So that's the graphed solution. Discounted fares are available to children 12 or under, 12 and under. Okay, so we're including 12, so x is less than or equal to 12. Or you can also get a discounted fare for an adult at least 60. So you could be 60, greater than or equal to 60. So if I put that as a interval notation, it would be from negative infinity to 12. They get a discounted fare, or 60 to infinity. I know, I made a mistake, and I made the mistake on purpose. I want you to find it right now. Okay, do you see what I did? These should be closed brackets, because you're including the age of 12 when you get the discount. You're including the age of 60 when you get the discount. Those should be included. It looks like this. Close circle going on up to infinity, close circle going on up to negative infinity. Now, there is an element of reality here. Your age cannot get below 0 when you're born. You know, you're at day 1. You know, it really can't go below an age of 0. So take that with a grain of salt, because you really can't have a negative 100 age. So that might be a good follow-up question here as to what are the real numbers that you could have for ages. And I would say actually real ages could go in between, but not including 0, because as soon as you get to day 1, you're no longer 0, and go up through 12. And then you can't have an age of infinity either. So that's something to think about too in terms of a real life context. This is 4v plus 3 is less than negative 5, or negative 2v plus 7 is less than 1. All right, so we're going to solve both of those separately. You're not going to ever see an or statement smushed together like you'll see an and statement, and that's just because they don't have that overlapping piece like the and statement has. If you notice with an and statement, if I scroll back up to the top, they both had this r minus 5 in common, and they both had this 2x minus 1 in common. That's not the case for the or statements. Okay, so we're going to solve this just like a normal equation. We are going to circle minus 3 minus 3. You get 4v is less than negative 8, and then you divide both sides by 4, and you get v is less than negative 2, or over here you have minus 7, and you get negative 2v is less than negative 6. You divide both sides by negative 2, and you get v is less than negative 3. Oh, I just made another mistake. And I noticed it because this one was v is less than negative 2, and this one's v is less than negative 3, and that's not an or statement. They're both going the same way. So what was the mistake that I made? When you divide by a negative number, you have to flip the symbol. V is greater than negative 3. I'm going to make another number line down here, so I'm going to print. I'm going to show you that you're at negative 2 or less, or negative 3 or more. Oh, and I made another mistake. This should be a positive 3. Negative 6 divided by negative 2 is positive 3. Positive 3 or more. And there you go. I'm going to have you do number 13 on your own. So I'm just going to check that one problem for an answer. I'm going to check to see if you did the rest of them, and then I'm just going to check to see what your answer is for that one. I'd like you to get an answer like this, where you tell me that you tell me that b is less than -2 and b is greater than +3, the two parts to it, and then I also want you to graph it.